So today we're in Mount Victoria, which is a well-known lookout point in the middle of Wellington City. So we've got a great view over the CBD, the harbour, and a series of hills on the other side of the harbour there. It's quite a straight line along that, and that's because at the foot of that is the Wellington Fault, which has lifted up the hills on the other side of the harbour and dropped the harbour down on this side. This is a very obvious fault. We've known about it for a long time, and as a result we've done quite a lot of work to understand it. There are also a number of other faults in the Wellington region, and you can see on this map what we're talking about. There's a lot of red lines. These are all active faults, and each of these could produce an earthquake. Today we're going to look at 4 of these faults to go and see what they look like in the landscape, and then we're going to think about the research that we've done on each of these faults to better understand the risk. So here we are at Makara Beach, where we're going to see our first fault, and we're going to go up here and have a look at these rocks up here. Okay, so we've come up to this outcrop now. What we can see is 2 different rock types. You can see this one up here which is more layered, and this one here which is more greeny, and the line in between is the Shepherd's Gully fault. So you can see right along the fault here is eroded out, and that's because the rocks are so crushed up, broken, they're quite soft, and so it's easy to erode it, and you can expand that to a larger scale, and we get these valleys that occur along all of the faults that form these really typical landscape features of the faults in this region. It goes down these valleys all the way to the south coast, and then it runs offshore and comes onshore again, and then goes offshore at Pukerua Bay in the north. So we don't know a lot about the Shepherd's Gully fault. There hasn't been a lot of work done on it, but there are some estimates of the recurrence interval, which is the average time between the earthquakes on the fault, and that's estimated to be around about 4,000 years. So that's one of the lesser active faults in the Wellington region.
So now we've driven up to the northeast to the Hutt Valley. Like at the Shepherd's Gully fault, we're seeing erosion that's picking out that fault line along the valley. There has been water that's pulled against this uplift, and it's making this kind of swampy depression here. Although we see this uplift on that side of the Hutt fault, most of the motion along this fault is strike slip. That means that the fault has mostly got sideways movement. You can see from these drone images that this fault is a really straight and clear feature of the landscape. So we know that the last earthquake on the Hutt fault happened about 1,000 years ago. We're less certain of the recurrence interval on the fault, but we think that this is around 2,200 years. So we've continued on along the Hutt fault, and now we're in a place called Patamata. We've seen this fault in the landscape down in the Hutt Valley, and now we're at a spot where this fault goes under this bridge behind me. So we've also seen that the ground on either side of this fault moves upwards or side to side. So from that we know that if there was an earthquake here, this bridge would be severely damaged. This is why we need to understand when these faults have had earthquakes in the past and how much they move, so that we can do what we can to protect ourselves from future earthquakes.
We've been over to the Tairua Fault, we've been to the Shepherd's Gully, and I'm on the Petone foreshore, and we're looking across Wellington Harbour, and that forested, bush-covered hill is actually one side of the Wellington Fault, which has been uplifted, as well as it's been moving sideways. And it's the sideways movement, but largely the up and down movement on the Wellington Fault that has caused the harbour to be here. It's the controlling landscape feature of the Wellington region. One of the key, perhaps scary features of the Wellington Fault is it goes through our capital city. We're now in Thorndon. I'm on the upthrown side of the Wellington Fault. We're looking across the Wellington Fault to the Thorndon region, and you can see a whole bunch of infrastructure down there, the rail, the ferry, the motorway. And a key aspect of the work that we do in the geology world is to provide the information on what a Wellington Fault earthquake will do, so the infrastructure here can be toughened and designed to accommodate that hazard. How strong is it going to shake? How much displacement? Where can the liquefaction happen? And all these aspects have been the subject of studies over a number of decades now. In the Thorndon region, we've mapped the areas that will liquefy, and structures that are built on that have been toughened to accommodate that, either having piles and foundations that go down onto non-liquefiable stuff, or in the case of the stadium, before they built it there, they pounded the bejeebas out of the ground to make it unliquefiable. Now I'm in Upper Hutt, the Kaitoke region, about 30-40 kilometers north, and I'm standing right on the Wellington Fault. These two manholes are one on either side of the fault, measuring strain that might be accumulating on the fault. And why we're here is I'm standing on the fault and the Stewart-McCaskill Lakes are not, and that was planned. So the Stewart-McCaskill Lakes are the region's main water reservoir. It's real good that it's actually not on the fault. So when the fault moves, these lakes are going to still be intact. And that's another example of how previous knowledge of where the fault is allowed critical infrastructure to be built away from the hazard.
We're at Tairua Head, which is about 20 kilometres east of Wellington. So to get here, we've walked along this gravel ridge, which looks a bit like a track, but it's not. It's actually an old storm beach that was created by the sea in storms, depositing gravel at the back of the beach. It's not the modern storm beach though. The modern storm beach is down there. And the reason this one is back here is that in 1855, the whole of Tairua Head was lifted up out of the sea by 6 metres. That was a huge earthquake, around magnitude 8.2, and that caused impacts around the Wellington region. You can see the whole staircase of ridges just going up the hill, and those represent uplift in a whole series of earthquakes in the past. We sometimes find shells like this on the ridges, and we can use radiocarbon dating to find out how old these shells are, and then that can tell us when the earthquakes happened. The dating tells us that it's uplifted every 1 to 2,000 years in an earthquake. The fault that caused this uplift is not far away from here. The Wairarapa Fault runs along this section of coast and then up past Lake Wairarapa. On the Wairarapa Fault itself is a really cool location at a place called Pigeon Bush. In 1855, at Pigeon Bush, one side of the Wairarapa Fault moved something like 18 metres past the other one, just in a few seconds. And we know that because there are small stream channels that cut across the fault. And when the earthquake happened, it took the bottom half of the channel and just moved it sideways, so it doesn't really match up with the top half anymore. So this offset in one earthquake of 18 metres is the single biggest documented offset of the Earth's surface in any earthquake anywhere.
So we've now been and seen 4 of the many faults in the Wellington region, but one we haven't been able to see is hidden beneath our feet. It's about 25 kilometres beneath us, and that's the Hikurangi subduction zone, which is the interface between the Australian and the Pacific plates. That is the region's biggest fault and can produce very large earthquakes. So it's really important that we research all of these faults to understand the risk, the impacts, how big they could be for the Wellington region, and we're doing that as part of the It's Our Fault program. So the It's Our Fault program here started in 2006. We have a team of people who are working on the active faults, on the Hikurangi subduction zone, on tsunami modelling, on landslides and fire following earthquakes, and getting all of this information into policy and planning to make the city more resilient. So we haven't experienced a large earthquake in Wellington for a while, so this is a really good time to get prepared for what could happen in the future. You can do your part by being informed, going online, finding out how you can get prepared at home, making your plans for what you can do in an earthquake.